Security issues come with two basic problems. Now, when you're designing a car, there are two terminologies commonly used, and one of which is the understeer, and the second one is the oversteer. Now, what do we understand by the term understeer? Understeer means something if you are going through a curvature, and in that curvature you're taking a turn of radius, say r, and you're covering a distance of r plus x. So that means your car is actually traveling longer than you're actually expecting it to drive. So it means understeer. And the opposite, the oversteer, it means that you are traveling a distance which is lesser than the curvature, and then you are traveling a distance of r minus x. So the distance traveled will be shorter. Now, there are many issues that come along with these two principles. And one of the most witnessing examples, that is the greatest tragedy of the last decade, was in 1993, the Ayrton Senna. He was the most succeeded and the most celebrated F1 driver. He was dedicated to his job, but it was just his philosophy. His very Banasic philosophy that caught hold of him. He was taking a right turn, if you're considering the rear view of his driving view, and he was taking a right turn. He had to take a right turn or else he would have gone off the track. So he was overtaking a personnel, a driver, and that driver was actually on the inner side of the turn. So if that driver wouldn't take the turn, he wouldn't have taken it. So he left the opportunity of taking that turn on that driver. And that driver didn't do it because he didn't want Ayrton Senna to win the championship. So if he would have had a counterpart of that solution, if someone would have judged that positioning, we would have definitely not lost Ayrton Senna today, and he must have been alive. And the countless innocent lives that are heard and unpoised, unanswered, and unreported every morning, every day. Ever since World War, there has been 1 million accidents throughout the world just because of car crashes. We have 1 million lives going away every year. It was in 1939 that the Second World War had taken place, and ever since that, considering roughly 70 years, 1 million people each year, that means 70 million people, 70 million people going away. And it was just 50 million who died in Second World War. They have already gone through a World War silently. Now you see the clusters over here. These are the very commonly used clusters, the companies who assure you that they'll give you one of the best, one of the fastest, one of the safest, one of the most extremist car that you can ever buy for your money. And they're never value for money. Maserati, Lamborghini, Murcielago, anything that you come up for. So my technology, it's called the steering, the UTR-Steering, and the initials are from my name. And please forgive me, Osama, don't terrorize yourself. I'm absolutely safe, providing a safety to your car. Definitely, contrary to the World War. So with this technology, the inspiration is from the very commonly used technology, that is the Ackermann steering wheel, the recirculating ball steering wheel, and the rack and pinion. The rack and pinion is the most commonly used steering wheel. Now here we see a Banasic steering wheel, as we don't see a piston here, so it's a very non-hydraulic. You can really create your muscles, you know, in case of Maruti 800, if anyone has tried it. Oh, very hard steering wheel. You can have a gym in your driving wheel. Wow. So speaking of this steering wheel, you have to have a lot of effort to steer your car. If you want to steer your car, you would have to have a rack and a pinion. And depending on the size of the pinion and the rack, you would have exchanged your views. Speaking of the rack and pinion, we have a hydraulic steering wheel here now. So the basic principle of the whole rack and pinion remains the same. It's just that we have added a piston. In that very piston, you're not pushing the rack or the pinion, you're just pushing the fluid. Pushing a fluid is a lot more easier than pushing any harder or a solid material. Now here is the basic principle of differentials that comes handy with the steering wheel. Now when you're driving a car at a fast corner, you need to have certain directions that you need to give. With that certain directions, you need to know that all the four wheels will be covering very different radiuses. The outermost top wheel will be covering the largest arc, and the bottom left wheel will be covering the smallest arc. So if you don't have four different motions in all the four wheels, you can definitely not take a personal or a very safe turn. Your car will tend to understeer or it will tend to oversteer. So this is the UTR steering. It means Uniform Traction Resistance. And it is synonymous to Osama Tariq Rashid. So, next slide please. The main essentials for this steering wheel is that you need not change a car for this. You need not go for an expensive modification. You need not go for anything that could be expensive in your budget. It's a very economical solution. All you need to have is a laser sensor, which is already available on the market, a motion sensor, which is again not a very common one, we are still developing the motion sensor, and the rotor valve. It is always present in your steering wheel. You don't have to change your steering wheel, be it hydraulic, be it non-hydraulic, be it power steering or non-power steering, it is all compatible. You need not have to buy another car for all of it. So as I told you, the laser sensors. Now, hoping to achieve that accuracy, hoping to achieve that high sophistication, we aim to build a laser sensor which will be rotating 1.3 million times a second. It has already been developed by the Russian army, but we intend to develop that for the Indian army. It is again for the unmanned drones, for the unmanned trucks, for the unmanned cars that go behind enemy lines. So this is actually a collaboration of all those lasers coming handy. So these laser essentials will be having a total of 15 lasers equipped in a single cylinder. And that single cylinder will be revolving. And that revolution will be giving you a complete picture of 20 meters of your radius. So before you go through any encounter or any life-threatening obstacle, these sensors will be telling you beforehand what is approaching you. And the next slide, please. The steering wheel is the basic principle here, and it has been explained here. As you see, the pinion and the rack are of any ordinary vehicle that you may have. But what is being controlled here is the pump and nothing else. The motion sensors will be controlling the inlet and the outlet valve. So the inlet will be in the direction, say, if you're turning right, and the fluid from reservoir will be going through the piston, entering the pump, and the vice versa if you're taking the left turn. So if you can control the fluid in the vehicle, there's one very important factor that comes important, and that is the hardening or the softening of the steering wheel. And that is the whole technique. If you can judge an obstacle 20 meters away from you just by knowing the hardness or the softness of your steering wheel, you can absolutely save yourself from any disaster. You cannot have any sort of miscalculation or misbraking or mishappening of any sort. And these are the very basic computations that go along with it. And that is, if you can control the centripetal force of any curvature, and your actually proportionality of that is being converged by your speed. So the speed that will be calculated by the computer will be under root UDR upon MT. As you remove the proportionality sign, you'll be having a Osama constant, and that is not a universal constant, it's just a proportionality constant. No values required, the values will be dependent on the parameters that you'll be judging. As I said, it will also be effective to the balance of the car, and it won't be disbalancing through the turns if you are taking a very high-speed turn. And then comes the struts, the balancing of the wheels, the rods. If you're taking an extreme turn, the left will be handled by the right, and the right will be handled by the left. So the very terrifying force is that you can have these economical solutions within $100 of budget, not a very expensive bargain. And for that, you need not have to spend your car's money into a very expensive car. You need not have a Ferrari. A Wagon-R will do. So the lust for speed is a very, very terrifying force. It plucks out the unworthy and takes them from earth. Thank you very much.
Now we begin our question answer session. Judges, if any questions from your side.
Thank you very much, sir. So actually this project is completely my brainchild. I have not consulted my juniors or seniors. I have been working with some of my professors. They tell me within a span of 3 years, you can definitely achieve. Yes, we have made a prototype of the laser because mainly we are struggling with the speed of the laser. If we can have a speed of nearly 1000 RPM, we can have that 1.3 million touches a second. So a collaboration of 5 seconds will give you that intense image to the software. So that's how it is.
You're not 25 years here. Why do you have such a huge ego? You have to have UTR calling it your name, constant view, that is again your name. I just wondering, is that a good thing or a bad thing?
So definitely seeing the positive end with the urge of having a mark on the international society by being an Indian, being Osama, and being all that I am. Just that, nothing else. No ego whatsoever.
You mentioned in your talk that you are putting the laser on a cylinder.
On a
Lasers,
cylinder.
multiple lasers.
Multiple layers.
And you mean to say that the cylinder is rotating at that speed?
Yes, the cylinder with the lasers within it will be rotating the module.
Is it extremely necessary to rotate that cylinder, or can there be switching between the lasers and then that can be done?
So if we
If I
can,
can put the lasers on an array,
Yes.
can I not switch them? In particular, because we are talking of 10⁶ revolutions.
Yes, yes.
That kind of thing. That's why this question.
so then we are actually having a nanosecond for me 1000 billionth of a second. So in that small particular parameter of time. Yes, sir. Mechanical, we consider mechanical just because of the economical issues. We just want to make it as user-friendly and environmental friendly as possible. Because electronics would have that battery in the rotation of the fluctuations of the lasers. We're just trying to make that as economic, environmentally friendly. That's it. No, I don't think we can have that option definitely, sir. But the main whole concept that has been achieved already was by this mechanical aspect and not by the electronic one.
Now the floor is open for the audience if they want to ask any question.
Anyone?
Anyone?
Thank you, Osama. Your presentation was good. My one question is, you do not consider friction. Then
Yes.
the friction and the position and condition of the tire and
Yes.
road.
Yes.
What will be the effect if the tire is slippery?
Absolutely, sir. That is what the whole aspect of lasers are. If you're having a laser that is rotating at that high speed, you'll have a sensitivity within the 20 meters of your radius, and that it will be telling you even a pothole, as sensitive as a pothole, as sensitive as an oil, if there is any. So if the hardness of the steering wheel is stiffening harder and harder, it means that you're going safe. You need not change your speed, you need not change your direction, the motion in which and the direction in which you are traveling is absolutely safe. And the softer it gets, it means the obstacle is very critical to your position what you are and at the speed at what you are. So you can do it by yourself and you do not have a computer to do it. So that is whole the fabrication.
In your formula, there is nothing mentioned about friction constant.
Yes, sir, because that
Or-
is just only for the hardness and the softness of the steering wheel.
Just constant or proportionally you consider as a friction constant or position condition of tire.
No, it's just a proportionality constant for the speed, for the governance of the speed. If your speed is high enough for not encountering that problem, you'll have to slow down. And that is what the calculation is basically all about. The calculation of the V under root the whole equation, that will be just telling you the whole aspect, whether the degree of safeness or hardness is being questioned.
Okay, I got a question. You were talking about potholes and oils on the road.
Yes.
Right. So do you know the Mercedes S-Class?
Yes.
You know, in India it's sold without the radar sensors and laser sensors because it is not used for civilians. You know, civilians are not allowed to use those technologies. So how are you going to tackle that? Because you use laser sensors that are not used for civilians. Apart from that, the problem of torque vectoring, that is the understeering and oversteering, that is already being countered by use of torque vectoring in the other cars.
Thank
It's already
you.
used in performance.
Question over. Time is over. So we can discuss this. You can explain him this to him later. And